So this time we have example number 2 of adding vectors using analytical method. So in this kind of method, again, we will not use any instrument to measure the length of a vector or the direction of the vector from positive x-axis in counterclockwise direction. We're just going to use the basic concepts of algebra, trigonometry, and geometry. Suppose you have two given vectors. You have vector A, which is 8 meters and 85 degrees counterclockwise direction from positive x-axis, and then vector B, which is 3 meters 140 degrees from positive x-axis in counterclockwise direction, and we'll look for vector A plus the negative vector of vector B, or vector A minus vector B, and it is represented by vector R. So we're going to draw these two vectors head to tail method. Then this is how it looks like. Now suppose instead of going that direction for vector B, okay, and this is negative vector B, then it goes to the opposite direction. So 140 degrees is measured from negative x-axis in counterclockwise direction. It will start measuring 140 degrees from negative x-axis and in counterclockwise direction. Now, so this time again we're going to use the analytical method. So this line here represents vector R as the resultant vector, or the sum of two vectors there. The magnitude of A is 8 meters and the magnitude of B is 3 meters. Alright, so can we use cosine law here? There is two sides and included angle. We don't know the included angle or the angle opposite to vector R. Alright, now this is 140 degrees, right? Now if I'm going to extend the line of vector A, remember that these two lines are the lines that are parallel to each other. So meaning vector A is the transversal line. It cuts the two parallel lines and create corresponding angles. Pair of corresponding angles are congruent. So if this is 85 degrees, from x-axis to vector A is 85 degrees, then this angle here also measures 85 degrees. Since these two angles are corresponding angles. Okay, next, opposite angles are equal. Vertical angles are equal. So if this is 85, so this is also 85 degrees. Straight angle measures 180. Now if this is 140, then this is 40 degrees. 140 plus 40 is 180. Alright. Now if this is 85 degrees and this is 40, so I'll mark this angle as angle phi. Alright. So angle phi equals, this is a straight angle, so it measures 180. So that is 180 degrees minus 85 degrees minus 40 degrees, and that is equal to 55 degrees. Right, so this is the angle opposite of vector R, or the included angle of side A and side B of this triangle. So this is the angle phi. So we can also for the magnitude of vector R using cosine law, since two sides are given an included angle. The included angle is the opposite angle of vector R. So let us use cosine law. So the magnitude of R is the square root of A squared plus the square of the magnitude of B minus 2 times A, the cosine of its opposite angle, which is phi, and we have phi here, that's 55 degrees. Okay, so R equals the square root of what is A? 8 meters plus 3 meters, 8 meters squared plus 3 meters squared minus 2 times 8 meters times 3 meters cosine of 55 degrees and that is equal to 6.74 meters. 6.74 meters. So we have now the magnitude of vector r. So next, how about theta as the direction of vector r from positive x-axis in counterclockwise direction? Now, if we're going to subtract 85 degrees by this angle theta of b, then we can solve for theta. Again, this is 85 degrees from positive x-axis to vector a, that's 85 degrees. And then if that is subtracted by theta of b, then we can get theta as the direction of vector r from positive x-axis counterclockwise direction. So that is 85 degrees minus theta of b. But what is this theta of b? How can we solve theta of b? So this time we're going to use the sine law. The sine law. The sine law is sine of phi over r, since that is the r is the opposite side of phi, which is equal to sine of theta of b over b. So we have sine theta of b and its opposite side is sine b, or sine theta of b equals the magnitude of vector b sine phi over r, or theta of b, that is equal to the inverse sine of b sine phi over r, and that is the inverse sine of the magnitude of b is 3 meters sine phi, phi is 55 degrees, over the magnitude of r, which is 6.74 meters. Then theta of b is equal to approximately 21.38 degrees. So meaning this angle measures 21.38 degrees. So if 85 degrees is subtracted by 21.38 degrees, then we can solve for theta. As theta is the direction of vector r. So this is 85 degrees minus theta of b, which is 21.38 degrees. Then we have theta equals 63.62 degrees. So we have vector r, magnitude of vector r, and theta as the direction of vector r from positive x-axis in counterclockwise direction. So we have vector r, which is this one, used to represent vector a minus vector b. So r here equals its magnitude 6.74 meters, comma theta 63.62 degrees. So you can double check the answer using component method. So that is example number 2. Bye.